Good afternoon, students. This is Pragnesh Polara from Om Engineering College again. And in this session, my aim is to teach you the topic of functions and limits. Okay, so first today we will start with the functions, and after clearing the idea of functions, we will move to some most important examples which are frequently asked in the functions from the chapter of function, and then we will move to the idea of the limit. Okay, so if we look at the PPT, then this is the definition of the function. A function f from set A to set B is a rule of correspondence that assigns to each element x in set A with exactly one element y in set B. That means a function is a relation which relates each and every point of set A with the unique element of set B. એટલે કે એવું રિલેશન કે જે સેટ એના દરેક બિંદુને સેટ બીના એક અને માત્ર એક પોઈન્ટ સાથે કનેક્ટ કરતો એવો જે રિલેશન છે એને આપણે કહેશું ફંક્શન. તો એ ફંક્શન આપણે એવું કહે છે કે તેમાં સેટ એનો દરેક એલિમેન્ટ આવી જવો જોઈએ. સેકન્ડ થિંગ કે સેટ એનો દરેક એલિમેન્ટ સેટ બીના એક જ એલિમેન્ટ સાથે રિલેટ થયેલો હોવો જોઈએ. સેટ એના દરેક એલિમેન્ટ આવી જવા જોઈએ, સેટ બીના દરેક એલિમેન્ટ આવે એવું જરૂરી નથી. દેટ મીન્સ each and every element of set A relates with the unique element of set B. This kind of relation is known as function. Here set A is the domain, or we can say the set of inputs, or and the set B is called codomain, or we can say the set of outputs which contains range of this function. Okay, so this is the formal definition of the function. This is some useful terminology for any function. So if we say that a function f is from A to B and f of small a is equal to small b, where a belongs to capital A and small b belongs to capital B, then what is the terminology we can use? We can say that capital A is the domain of the function, or we can say domain of f. B is called codomain of f. Okay, small b is called the image of small a under the function f. Okay, small b is called the image of small a under the function f, and inversely we can say that small a is a pre-image of small b under the function f. This is very useful terminology because in future we will going to use all this terminology. Okay, so here capital A is called the domain, capital B is codomain, small b is the image of small a, and small a is the pre-image of small b. And general, we can say that B may have more than one pre-image as per the definition, because as per definition we have says that each and every element of set A connected with the unique element of set B, but not for that for set of B, because so set of capital element of set B may be connected with more than one element of set A. So we can say that small b may have more than one pre-images in set A. Okay, the range of the function called R is always from the codomain. That means range of f, that is R, is always subset of B. Okay, or we can say that B, there exists a f of A is equal to B, right? So this is the terminology. For more understanding, we will look at this figure here we can understand the terminology of the function very easily. Here we have two functions r and z. If we define the function from f from r to z, okay, this is the function f from r to z, and this is the one element 4.3 in the domain of f, which is r. This is the image of 4.3 under the function f, which is in the codomain z. So image of 4.3 under the function f is 4. Okay, we can say r is the domain, z is codomain. We can say 4.3 is the pre-image of 4, or we can say that 4 is image of 4.3, and this is the function f which maps r to z. Okay, so this is the better understanding of terminology of the function. If we look at more some examples of function here, this is the class grade function which relates every students with their grades. So here we can say that in set A there is the name of students Alice, Bob, Chris, Dave, okay, and in the set B there is a grade. So we can say that each and every element of set A is relates with the unique element of set B. So this is the function. Okay, here it is not necessary that the every element of set B should be relates with set A, because here we can say that the element capital B of the codomain is not relates with any element of the domain. Then 2, this is the function, because as per definition this is function, because each and every element of set A is in relation with a unique element of set B. If we look at, this is domain, this is codomain, and if we look at one more example, this is a string length function. So we can say that here also this is the function, because each element of set A is connected with unique element of set B. So this is also function. This is two more examples of function for the better understanding. Okay, if we move to next, we can say that this one is the pre-image of 1, and we can say that 1 is the image of image of small a. Okay, image of small a is equal to 1, or we can say that pre-image of 1 is small a. Okay, so that are some basic functions. If we look at the arithmetic of the function, then if we have two functions where f1x is equal to 2x and f2x is equal to x square, then f1 plus f2 is equal to f1 plus f2 applies on x, then that is equal to f1x plus f2x, and we have given that f1x is equal to 2x and f2x is equal to x square. So f1x plus f2x is equal to 2x plus x square, and in the same way we can say that f1 into f2 is equal to f1 into f2 applies over x. So f1x into f2x, that is equal to 2x into x square, which is equal to 2x cube. If you move further, then we can moving to the 1 function. There are many types of function. There is 1 function, there is many one function, onto function, into function. We are quickly discussing all these function by one. So first we are going to discuss about the 1 function. So if we look at the PPT here, a function which is 1 to 1 if each element in the codomain has a unique pre-image. Okay, that means one element should be related with one element of codomain. Okay, so if each element in the codomain has a unique pre-image in the domain, which is called one-to-one function. Or if we want to say it mathematically, which kind of function we can say that this is one. So if we look at here, we can say that if f of x1 is equal to f of x2, if f of x1 is equal to f of x2 implies x1 is equal to x2, that means if the value of x1 and x2 under the function is same, then directly that implies x1 is equal to x2. Otherwise this is not possible. If this happens for any function, then we can say that f is one-to-one function. Okay, this is the mathematically definition of one function. Or in other way, we can also say that if x1 is not equal to x2, then implies f1 x1 must not be equal to f of x2. If this holds for any function, then also we can say that f is one-to-one function. Okay, these are both are mathematical form of one function. Or verbally we can say that a function is one-to-one if each element in the codomain has a unique pre-image in the domain. Okay, so this is the definition of one-to-one function. This is the diagram for the one-to-one relationship. Here A relates with 1, E relates with 4, I with 5, and O with 2. So this is one-to-one. And by the definition, here each element of codomain 1, 2, 4 and 5 are relates with the unique element of set A, that means with a unique pre-image. Okay, so this is a one-to-one function. This is one more example of one-to-one for the one-to-one function. But if we take notice that here the element 2 is relates with two elements of the domain E and O. So by definition here 2 has not a unique pre-image in the domain. So this is not a one-to-one function, because here A, by mathematically we can say that here A is, so here E is not equal to O, but f of E is equal to f of O is equal to 2. So this is not one-to-one function. Okay, now our second definition is onto function. Before we going to the onto function, we can we want to discuss about the many-one function. So very easily we can say that if any function is not one, then it is many-one function, because one many is not a function, that is a relation. But we cannot say that is function, because one many is a relationship but not a function. But many-one is a function. So we have two types, one function and many-one function. So we can say that if a function is not one, then it is many-one function. Okay, then if we look at the PPT, then the other one is onto function. Okay, so definition of onto function is a function is onto if each element in the codomain is an image of some pre-image. Okay, that means till now we discussed that each element of set A, should be related with the element of set B, but not for the set B. If any element of codomain is moving, then it is okay for the function. But if we want to discuss about the onto function, then for the onto function, all elements of set B must be relates with the any element of set A. Okay, so by definition we can say that a function is onto if each element of the codomain is an image of some pre-image. That means if we discuss more about this definition, we know about the range of the function. So by mathematically we can say that if range of the function Rf is equal to the codomain, then that implies that function is onto function, because normally range of f is always subset of B. That is clear because all elements of range are coming from set B, so range of f is subset of B. That is always happens, but sometimes range of f is equal to B, and when range of f, when it happens range of f is equal to B, then this kind of function is called onto function. Okay, so this is the mathematical definition of onto function when range of f is equal to B. So if we want to prove that any function is onto function, then we will first find the range of that function, and we will prove that range of the function is equal to codomain. So that is the definition, mathematical definition of onto function, and verbally we have discussed that onto function is looks like this definition. Okay, so this is about the onto function. This is the one example of onto function here, and this is not onto function because these two elements 3 and 4 are not image of any pre-image from the domain. So here